the next topic is something called Mach. By the way, not Mac. Okay, Mac is this. This is Mac, like McDonald's, for example. No, Mach is an Austrian name, like a German Austrian name. Mach number is a name, is a concept, basically what named after Ernest Mach, was an Austrian physicist from Austria, who basically what studied a lot about sound waves, and not just any sound waves that travel very fast, sound waves that travel very fast, or objects that could travel maybe not faster than the speed of sound back in his days, but at least very comparable or very close to the speed of sound. So basically, he just what he studied it and then devised an equation, which is a very easy equation for what for relating the speed of the sound around an object to the speed of the object itself. Okay, nothing. I mean, the concept itself is very important, but the equation is very surprisingly simple. So it's basically the equation is air speed of object, or just what? Sorry, just the object speed. So object speed, object speed over just the what? The speed of sound speed. That's it. By the way, very important to remember, it's not the other way around. So they often the mistake is people divide sound speed divided by object speed. No, you are relating the speed of the object to the speed of the sound. So that's why the object speed has to be on top, and then the speed of sound has to be on what? On the bottom. Good news about this equation, everyone. Good news. Technically, because it's a ratio equation, everyone, it's a ratio equation. Two things here. Number one, no units. No units. Why? Remember, we did that before twice so far. So let me just go back to I'm just going to talk to everyone. So we did this twice so far. We did it with the mu s and the mu k. Why? Because we divided force by force. Remember, mu s was fs over fn. The newtons canceled out. Also fk over fn. The newtons canceled out. The second time we did it was a few weeks ago when we talked about efficiency. Efficiency, when we did energy and work. Efficiency was what? Energy output over energy input, or work needed divided by work done. Either way, it was joules dividing joules, which means the units were gone. Although in efficiency we multiplied by 100%, because basically it made more sense to talk about machines with a percentage instead of just a decimal or a fraction or so on. Same thing here. This is our third time having no units, okay, which is the Mach number. The Mach number is what? Is a unitless or dimensionless number or value, okay, because it's speed over speed, which is why it's good news, because your speeds could be in kilometers per hour or could be in meters per second. They just have to be the same thing twice, okay? You cannot divide meters per second on top over kilometers per hour at the bottom, or vice versa. Either you choose both of them to be meters per second, or you choose both of them to be kilometers per hour, but you cannot have a mix and match between units. Both object and sound speed have to be the same thing, okay? So let's just read this quickly here. So, yep. So note that the ratio has no units. Got that one explained. No units right here. For this reason, when describing the speed of an object using Mach number, by the way, here's the thing. We do not say, oh, that object is traveling at 1 Mach, 2 Mach, or 3 Machs, because then it makes the Mach a unit. No, the Mach is actually called Mach 1. Mach 1 means it's perfectly traveling at the speed of sound. Mach 2, it's traveling at twice the speed of sound. By the way, that's insanely huge. Very super fast, okay? Mach 3 and Mach 4 and so on, okay? So Mach 1, for instance, means the object's traveling at the speed of sound, okay? So the object is traveling, is going through the air as fast as the sound waves going around it are also going through the air itself, okay? Mach 10, which is unbelievably fast, that's going at 10 times the speed of sound and so on. So I just want you to think about one thing here. This is just a ratio measure of how fast something is. By the way, is it Is it relevant to talk about the Mach number of a car outside? No, because the Mach number of a car outside is going to be very, very small because it's barely even traveling at the speed of sound. Okay, you only really need Mach numbers, or they become more and more relevant and important and practical when you're really getting closer to the speed of sound, when the object speed is getting closer to the speed of sound around it, not when it's very, 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 very behind. Okay. Okay, everyone, let me give you an example. Really, really quick example. I might ask you a question. Here's a question: how fast is sound traveling in kilometers per hour? Okay, well, you know what? I always like to use the quick number 330 meters. I know at 0 degrees we said it's 331.4, but let's keep things simple. So if someone says Vs is 330 meters per second. Okay, how much is that in? Sorry, how much is that in? How much is that in kilometers per hour? Well, the magic number is multiply by 3.6. So 330. I'm just trying to give you an idea why Mach numbers are not important for us or for cars or even for regular planes. So 330 times 3.6. So sound speed in kilometers per hour, if it's 330 meters per second, is 1,188 kilometers per hour. So imagine if you're going at highway speed. Well, highway speed will mean the velocity of the object, speed of the object. We don't really care about directions here. Velocity of the object is like, let's say you're gunning it at 140 kilometers per hour. You're 20 meters, because you're 20 kilometers per hour above the maximum speed limit, because officially you're 40 above the 100. Okay, so what's your Mach number of this car? Well, speed of object over speed of sound, which is what? Which is just 140 divided by 1188. So how much is that? Well, we know it's way less than 1. Mach number of this car is 0.117, or basically, even if we're generous, 0.12. That's very, very, very low. So obviously we know that this car is not really to be talked about with speed of sound comparison, because it's very, very low. Okay, so I'm hoping that makes sense. You only need to really care about it if it's going very fast. Yes, and yes, I just saw that you had a hand up.
Isn't it like how like the Flash and like really fast people travel?
Yes, you're absolutely right. Everyone, I mean, you only really care about Mach numbers if basically you're talking about what? Supersonic jets. Supersonic means flying faster than the speed of sound. By the way, I do know one thing. I know that yesterday's lesson, supersonic meant something vibrates at higher than 20,000 20,000 hertz or 20 kilohertz. So supersonic, if you talk about frequency, you are going to have to relate it to 20,000 kilohertz. If you're talking about speed of sound, you're going to have to relate it to what? Faster than the speed of sound around that. But Yazan is 100% right. You only care about that if you're traveling very fast. So the Flash, for example, is traveling almost at the speed of light, which would be really like a huge, sometimes Mach number, even compared to the speed of sound. Okay, it's just a number that really becomes relevant only for very, very, very fast objects. Okay, so let's do a couple of quick examples here. So if the local speed of sound, don't worry about the word local, just if the speed of sound somewhere is 344 meters per second, and an aircraft is flying at 910 kilometers per hour, what is the Mach number of that aircraft? So remember, we can't do this now, not because it's a hard problem, it's because it's what? It's different units. So I'm going to show you both ways. I'm going to prove to you that the Mach number is going to be the same either way you do it. So let's say that we want to do things in meters per second. Okay, so here I'm going to call it the meters per second, and here we're going to do them in kilometers per hour. All right, so meters per second. Well, the V sound, the Vs is already given in 344 meters per second. It's the V object that needs to change. Well, because it's already given in kilometers per hour, we need to divide. Remember, kilometers per hour need to be divided, or you need only 1 second now. So you divide it by 3.6. So 910 divided by 3.6. How much is that? Well, let's see. 910 divided by 910 divided by 3.6. So 252 point, I'll go with 252.8. 252.8 meters per second. Right there you see, this is going to be subsonic. This object is traveling at 250 meters per second. The sound around it is traveling at 344. So this is way traveling what? Below the speed of sound. So we know that the Mach number is going to be less than 1. So you just say M equals 252.8 divided by 344, which is equal to 252.8 divided by 344, 0.734 or just 0.73, because this is 3 sig figs, but this is 2 sig figs. Remember, zeros with whole numbers do not count. There we go, 0.73. Okay, let's do it in what? In kilometers per hour now. So the V object now is in kilometers per hour, so that's the thing that stays the same. Now we have to change the speed of sound. So 344 times 3.6, because I'm going from seconds to hours. So 344 times 3.6, 1238.4. 1238.4 kilometers per hour. You see, still, the speed of sound is faster than the object. It doesn't matter what unit system you do it. Okay, so M equals 910 divided out by 1238.4, which is, by the way, focus on this number, 734. It's got to be the exact same number infinitely to all the digits. It has to be, because it's the same thing. 1238.4. Check it out. It's the exact same number up to, why is it different? 344.3.6, 9.2. Did I make a mistake? 9. It should be the same. Anyway, but it's exactly 0.73. Remember, no units. No units. Nothing. No units. Okay? That's basically it. That's how we do the Mach number for it. Okay, let's do another problem where I give you the Mach number. I'm going to ask you about another speed. So basically, we're going to do what? Cross multiplication. Cross multiplication. Why? Because I have a fraction on one side. I'm going to make the other side a fraction as well by putting 1 under it. So the Mach number is 0.93, which means this object is not traveling faster than the speed of sound. It's traveling almost at the speed of sound. Because remember, if it's 1, everyone, if the Mach number is exactly 1, it means 100%. It's exactly as fast as sound. Bigger than 100% or bigger than 1, that's faster than sound. Lesser than 1 or lesser than 100%, which in this case is 93%, because that's what this decimal is in percentage, it's traveling very close, but not quite to the speed of sound. So the Mach number is 0.93. And the speed of sound is 320 meters per second. What's the speed of the airplane? They didn't say what unit they wanted. So let's do it in meters per second. And then to have a physical relevance of it, convert it at the end to what? To kilometers per hour. Yes, start. Go ahead.
Sorry to bother. Can you go back to the last slide?
Yes.
Does it make sense? 210 km and then goes to 252 meters per second.
Sorry, you're talking about this line right here?
Yeah, shouldn't it be more meters? Because it's km now, kilometers.
No. Thought it. 910 kilometers in a full hour. In a full hour.
Oh, okay.
So think about it this way. Okay, everyone, in case anyone was uneasy about this, 910 kilometers per hour means 910,000 meters per that hour.
Yeah, I didn't see the hour.
Yes. So now if you can go 910,000 meters in 1 hour, 1 hour is 3,600 seconds. Divide that 910,000 by 3,600 seconds, you are able to cover a distance of 252.8 meters in 1 single second. Okay, glad someone asked. Again, everyone, you know me. It doesn't matter how simple the question sounds. It's an important question no matter. If it's a question, it's important. Okay. So what's the speed of the airplane? Okay, I guess we can just do the equation first. So M equals V object. Remember, if you put the V of sound on top, you're going to get completely the wrong answer because you're going to basically get the opposite of what you want because you flip the division. So it's always V object over VS. So here it's 0.93 equaling, this is the speed of sound. So this number goes down, 320, and V object is up, and our good friend 1 is right here. And then we just cross. So this will lead to V object times 1, which is just V object, so good news, nothing here, is equal to just 0.93 or 93% of 320, which is expected because it has to travel slightly smaller than the speed of sound. 93 times 320, 297.6. 297.6 meters per second. What's the sig fix situation? 2. So this will be 200. See, now you have to use scientific notation because if you put 300, that's only one sig fig. So it's 3 point times 10 to the 2. That's 10. That's 300 in scientific notation. Yep, which is right here. Let's multiply it by 3.6 to see how fast it's going in kilometers per hour. Sorry. 3. You know what? Let's multiply the original number, 297.6 times 3.6. It's going at 107. So if I 107, 1 kilometers per hour. And if you make this in 2 sig figs, yep, you do get 1100 kilometers per hour. Okay, so this is how we use this equation. This is how we use this equation for what? For this is how we use this equation if we're given the Mach number and one of the speeds. Okay, we just have to crisscross. We cannot escape that. Okay, the easy one is if you're given both speeds, because you just divide, and that's all there is to it. Okay, I'm gonna give you a little homework problem. Okay, I will still release the solution tonight, don't worry, but let's just come up with some numbers here. Okay, so let's say, everyone, an object. So I'm just gonna write it down. So an object, let me actually do the view with the grid lines. Yes, good. So an object has a Mach number of, okay, let's see. Let's say it's 1.1. Okay, everyone. So the first piece of information let me just check here. The first piece of information is that some object obviously traveling very fast because it's more than one Mach number of 1.1. That's the first thing you know. The second thing is its speed is 1,235 kilometers per hour. Okay, I'm just trying to see. Yeah, I think that's good. Okay, its speed is 1,235 kilometers per hour, not meters per second. That's almost impossible. Okay, 1,235. Okay, impossible for not light, impossible for an object of like actual mass and dimensions and stuff. The question is simple. What is the temperature? So you see how now relating this slideshow, temperature, relating this slideshow to the what? To the first slideshow. So think about it. The only information you're given is Mach equation. So your first equation to use is the Mach equation. And the only speed you're not given is the speed of sound. So the first thing you have to find is the speed of sound. And then you go back to the old equation and you find you reverse engineer it to find the temperature after finding that speed of sound. However, you still have one extra step you need to convert things to meters per second. Because remember, we learned two equations today, everyone. We learned two equations today. This one, the second one we learned, the Mach one, is the one that's easy. It does not care about units as long as the units are the same. They don't have to be standard meters per second. But the old one, guess what? You're stuck. That old one that we learned today, the one with the temperature, is an actual physics equation, which means all the units have to be physical standard, which means temperature in Celsius and speed has to be either given or found to be in meters per second. Okay, so that's your little homework. Should not take you more than 5 to 10 minutes, even after reviewing and so on. By the way, I have no idea what the answer is. You just saw me. I came up with the numbers. Okay, so just find out what is the temperature of the air that makes an object traveling at 1,235 kilometers per hour be able to be registered as Mach 1.1. Okay, and that's basically